Good evening. Yesterday, we covered some problems of differentiation. There is no end to that. I cannot claim, or anybody cannot claim that we have completed everything. It's not possible to work all types of problems, all problems. Rather, different types of problems, I have just covered it. I hope through those problems you have learned some methods. Let's move on to the next concept, integration. I presume that all the students who are attending this are familiar with all the formulas. With that assumption, we'll start the first problem for today's class. X into root of x plus 1 dx. Normal procedure in integration, whenever a problem is given, we should see whether we can work this using any standard formula. So there is no standard formula. And that doesn't work out, then we go for substitution method, then integration by parts, all those follows. Will the substitution method work out? Let us see. Let us put x plus 1 equals b. X plus 1 equals b. You get dx equals dt. See, in substitution method, you should be aware, once you bring in t, it should be possible for us to express all the x into t. Is it possible? Definitely possible. How? X plus 1 is t. So what is x? It is t minus 1. And what is this? This is root t. Now multiply this. This is t to the power of 3 by 2 minus t to the power of half. So 3 by 2 plus 1 is 5 by 2. That is 2 by 5. What is t? X plus 1 to the power of 5 by 2. Half plus 1 is 3 by 2. That is 2 by 3. X plus 1 to the power of 3 by 2. They would have given 4 answers. Search for the right answer and take this. So we follow the proper procedure. First thing is, we will see whether we can work this using any standard formula. Whether it's the problem of standard integral. When that doesn't work out, we go for substitution. Now, let's go to the next problem. It is secant square root x dx. Now here, secant square is there. I cannot take secant root x st or secant, because when we differentiate secant, we are going to get secant and tan. So there is no question of taking secant st. The only possibility here is, and it is not a standard problem. See, some students will always get confused. Secant square x is tan x plus c. So because root x is there, and that would be one of the answers given also. The examiners will give the 4 answers, which are the possible mistakes the students might do. So that may be the first answer, and you take that. Now you can't work using secant, taking secant as t. The only possibility is we are going to work out. Supposing I take root x as t, I'll get 1 over 2 root x, only those are not there. The only possibility is, let us put x is equal to t square. Why should we take t square? Because root x will become t. So if x is equal to t square, what is dx? Dx is going to be 2d dt. The problem will become 2 into t secant square t dt. It's a product. When you have a product of 2 different types of function, supposing they are both the same function, algebraic function, we can multiply. If it is both are trigonometry, we can think of whether we can simplify it. There is a method called integration by parts. You are familiar with it. That is applicable for problems, product problems. Remember, the product of two different types of functions. Here it is, trigonometric and. So, what the rule we follow? I stands for inverse, L stands for logarithmic, A stands for algebraic, T stands for trigonometric, D stands for exponential. Now you have got algebraic and trigonometric. Trigonometry comes after algebraic. Therefore, the first function we are going to choose, u is going to be algebraic. So put u is equal to t. The second function, dv by dt is equal to secant square. So what is du by dt? Du by dt is equal to 1. What is v? V is tan. So what is the formula? Integral u dv is equal to uv minus v dv. Third form. So this is 2 is outside. T secant square t dt is 2 is outside. uv is t tan t. T tan t minus integral v tan t dv by dt is. So this is 2 into t. What is t? T is root x. Tan root x. What's the integration of tan t? Log secant t. So log secant root x. I was speaking to you yesterday also, today also, same thing I am telling you. The more you work problems of previous papers, you will be able to catch the method. The moment you see a similar problem, immediately you are able to recognize the discussion that has happened in the class, or you have worked on your own, you can do it. That is what I said, familiar problems. Though the problems are not the same, at least you should be able to recognize the method that you are going to employ. Here it's a combination of trigonometric and algebraic, therefore we are going to go by integration by parts. Let's go to the next problem. This is the most simplest problem you can ever think of, and this has been asked in the public examination. Still I am working, just remind you. So you have to remember the formula, e to the power of x, the f of x plus f dash of x dx is equal to e to the power of x into f. Please note this point. If you notice e to the power of x in an integration problem, it must be this one only. I can say 100%. Because in CET they can't give any other problem. But the only thing is, here sometimes it is not given directly, you have got to do some simplification. But you have to remember this formula. Least assured that it must be this only, if e to the power of x is there. So we have to arrange it. So you can write this as e to the power of x into secant x plus secant x tan x dx. So this is f of x and this is f dash of x. So the answer is e to the power of x into secant x. It's going to be a very simple problem. You have noticed that. The next problem. This is given just to confuse you. Sine of x by 6 plus cos of x by 6 dx. It is not sine square and cos square. It is sine square and cos square. Sine square x plus cos square x is one that we could have. This is just to confuse you. It's the most direct problem. Sin is minus cos x by 6 divided to 1 by 6 minus, and cos is sin x by 6 plus. Sometimes when I am working a difficult problem, in such a direct problem, simple problems are given, students are not able to recognize. That's why I keep telling you, right from the beginning till the end, till you complete a paper, have patience. I have given all those instructions in my first class on Saturday, how to go about it. The moment you notice an unknown problem or a difficult problem, unfamiliar problem, you can just leave it. And most often, the problem is familiar with the minor changes. The next problem they have given is e to the power of x over x plus 1 whole square. As I said earlier, the moment you see e to the power of x, it must be of the form e to the power of x, f of x plus f dash of x. No other problem can be given in CET. You can take my words. Now, but it is not in that format. So if you had worked this earlier, okay. If you have not worked this, learn the method. So what we do for this problem is, we write this as x plus 1 minus 1 and separate it x plus 1 whole square minus x plus 1 whole square. If you simplify this, you get rid of the power of x over 1, x plus 1 will cancel. 1 over x plus 1 minus x plus 1 whole square. So this is f of x, this is f dash of x. Therefore, answer e to the power of x. I would rather suggest this must be a familiar problem for you. So the more problems that you work will be helpful for it. You can't just think of the method there only. Such problems where you are totally familiar, not familiar, and apply your intelligence work should be less than 10. Out of 60, 45 problems should be familiar one. It is possible, definitely possible, if you are preparing properly for the examination. Okay. They have given one more problem. The next problem rather, e to the power of 2 log sin x. The moment you say e to the power of log, you should remember e to the power of log of f of x is f of x. But you find 2 here, then you should use the formula n log m is equal to log m power n. So once you know these two formulas, it is a very simple problem. E to the power of log of sin square x. That is nothing but sin square x. What is integrate sin square x? A very familiar problem, half of 1 minus cos 2x dx. So half of x minus sin 2x by 2. Easy flow. The moment you see sin square x, you should remember cos square x is half of 1 plus cos 2x. The trigonometric formulas will come for your rescue provided you have started using them. Next problem they have given. Cot x into root cosecant x. Cot x into root cosecant. You can't combine them. If it is cot x cosecant x, you would have written it as minus cosecant x. But root is there. So you have got to use trigonometric simplification. This can be written as cos x over sin x to the power of 3 by 2 dx. That was your first step. How? Root cosecant x will come down, it is root sin x. Cot x is cos x by sin x. So 1.5. Then it's so easy, it is put sin x is equal to t. Cos x dx is dt. So it is t to the power of minus 3 by 2 dt. Minus 3 by 2 plus 1 is minus of 1 over root t plus c, 1 over root sin x plus c, or it is root cosecant x. See, while giving answers, they might have given, of course, another one. It will be minus 3 by half. So divided by half will be 2 here. So 2 will come here. This is 2 root cosecant. Because t to the power of minus 3 by 2 will be equal to t to the power of minus 3 by 2 plus 1 by minus 3 by 2 plus 1. That is t to the power of minus half by minus half. That will come up. And it is going to be negative. Minus half, therefore minus sign minus sign. So you have got to take the right answer. Dx over 2 to the power of x plus 2 to the power of minus x. The moment you see this, you should recall a similar problem that the teacher might have worked in the classroom. What is the method for this? E to the power of x plus 1 plus e to the power of x. You take LCM, you get e to the power of 2x plus 1, put e to the power of 2x. E to the power of x is equal to 3. E to the power of x. This is a familiar problem. Same method you can follow. This is 2 to the power of x. This is 2 to the power of x whole square plus 1 square dx. So put 2 to the power of x is equal to t. 2 to the power of x into log 2 dx is dt. So 2 to the power of x dx is 1 by log 2 dt. So this 1 by log 2 integration of dt over t square plus 1. That is 1 by log 2 tan inverse of t. Tan inverse t is nothing but tan inverse 2 to the power of x plus. So these two problems are same method. This problem definitely teacher would have worked in the class. How fast we can recognize that? How fast you can relate the problem given to the problem that you work? That is possible when you are putting efforts. Nothing comes easily. You need to work as many problems as possible. Not left many days already. It's fourth year exam. Hardly 10 12 days left, I think. The next problem is sin x over root of 1 plus sin square x. You can't rationalize, and if you put sin x as c, no, you won't get it. So one idea you should get, you should choose a function that will differentiate it, should give us sin x. That is only cos x, but they have not given cos x. So this is a hint for you. Whenever sin x dx in numerator, differentiating a function you should get sin x dx means you need to differentiate cos x only. But cos x is not given. They have given sin square x. The first thing that you should do is you have to convert that sin x to cos x. This must be your first step. Sin square x is 1 minus cos square x, 1 plus 1 is 2. Now what is your t? Put cos x equals t. Now this is where we fail to score. When you work the problems, number of problems you work, you're exposed to all types of problems. The moment you see, you just get a solution and you will not find it difficult. This is what I'm suggesting you. There can be unfamiliar problems to the extent of 5, not more than that. At the most 10. And 45 questions should be very simple, and another 10 questions you need to do some exercise. It is possible. See, normally, when you are prepared very well, the moment you see the problem, our brain is able to recollect what we have done, provided you worked. I always tell the students, ನಿಮ್ಮ ತಲೆಯಲ್ಲಿ ಇದ್ರೆ ಹೊರಗಡೆ ತೆಗಿಬಹುದು. ಮತ್ತೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಹೊರಗಡೆ ಬರಬೇಕಾದ್ರೆ ತಲೆಗೆ ಮೊದಲು ತುಂಬಿಸಿರ್ಬೇಕು. ವರ್ಕ್ ಮಾಡಿದಾಗ ಆಟೋಮೆಟಿಕಲಿ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೆ. ನಮ್ಮ ಬ್ರೈನ್ಗೆ ಆ ಕೆಪಾಸಿಟಿ ಇದೆ. ನಾವೊಂದು ವಿಷಯ ನೋಡಿದ ಕೂಡಲೇ ಅದನ್ನ ರೆಕಗ್ನೈಸ್ ಮಾಡೋಕ್ಕಾಗುತ್ತೆ. ಈ ಲೆಕ್ಕನ ಈ ಕ್ಲಾಸಲ್ಲಿ ಮಾಡಿದ್ದಾರೆ. ಇನ್ಫ್ಯಾಕ್ಟ್ ಎಷ್ಟೋ ಸಲ ನಮಗೆ ಎಕ್ಸಾಮಲ್ ಪ್ರಾಬ್ಲಮ್ ನೋಡುವಾಗ ಆ ಟೀಚರ್ ಕೂಡ ನೆನಪಾಗ್ಬಿಡ್ತಾರೆ. ಆ ಟೀಚರ್ ಹ್ಯಾಂಡ್ ರೈಟಿಂಗು, ಅವ್ರು ಯಾವುದೋ ಒಂದು ಕಾರ್ನಲ್ಲಿ ಬರ್ತಿದ್ದು, ಪ್ರತಿಯೊಂದು ನೆನಪ ಅಂದ್ರೆ ಅಷ್ಟು ಇನ್ವಾಲ್ವ್ಮೆಂಟ್ ಇರುತ್ತೆ. ದಿಸ್ ವಾಟ್ ಐ ಆಮ್ ಸ್ಪೀಕಿಂಗ್ ಔಟ್ ಆಫ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್. ಬಟ್ ನಥಿಂಗ್ ಹ್ಯಾಪನ್ಸ್ ವಿತೌಟ್ ಹಾರ್ಡ್ ವರ್ಕ್. ಇನ್ನೇನು ಡೇಸ್ ಉಳಿದಿದೆಯೋ, utilize it properly and see as many problems as possible. So if you put cos x as t, sin x dx is minus dt. The mind has to work so fast. You know that. No need of writing also. But here I am writing minus dt over root of root 2 whole square minus t square. So immediately the formula should come to your mind. A square minus x square is sin inverse x by a. So what is your answer? Minus sin inverse. What is x? X is t. That is cos x by a is root 2 plus. In the regular class we write for sin inverse t by root 2. And here no. And you are not writing also. What I would say is, the moment you write this, you write all oral thinking. Cos x will get minus I, and this is root 2 whole square minus t square. Immediately you take the answer. Or else you can differentiate and do it, but that will take more time than thinking. Some problems can be differentiated, the answer, and you can get the solution. Not all problems. Please note this. Some of the integration problems you can get into the answer by differentiating it. All problems are not possible. Especially when root and inverse functions are there, don't make an attempt to differentiate, because that will take more time. This is another very interesting problem. Cos 2x over cos x minus sin x whole square. While working this problem, you should appreciate the examiner, the person who has constructed this problem, not me. I have only borrowed from the books. That is why my contribution is I have borrowed the problems. I only selected the problems which will, by working that, your depth of knowledge integration increases, and you are exposed to little more thing. That's the intent. The entire interest of taking this class to give you little more depth. So what my contribution here is, I have selected the problems. I feel these are the problems where you can think one step ahead. The more work you give to the brain becomes more active. See, normally some students will think cos 2x is there. Immediately, why not write it as cos square x minus sin square x? Okay, write it. Then what do you get? Cos x plus sin x over cos x minus sin x. Denominator has got cos x minus sin x whole square. One will cancel. Again, you get this. So it is not possible. Again, you have to work it out. That is not the method. So what is the method? Can we think of all these possibilities in the exam? Definitely not. First of all, we don't have time. Second thing, we don't have paper also. So this should be a familiar problem for you. So what you can do is, you take cos x minus sin x whole square itself as t. We're going to use chain rule. This is 2 into cos x minus sin x minus sin x minus cos x dx is 3. So what do you get here? Minus sin x minus cos x. So you can write this as, you can take minus common. Cos x minus sin x into cos x plus sin x dx. Now you can use that. Cos square x minus sin square x dx is equal to half minus half dt. This is cos square x. Therefore, this expression is going to be cos square x. This is t to the power of minus 2 no. This is dt by t only. dt by t. Because you are taking cos x minus sin x whole square as t. So this is log t plus c. That is log of cos x minus sin x whole square plus c. But you will see in the answer, whole square is not there. They would have shifted this. And be careful. Log m power is n log m. That's a normal way of. And one more thing is, there is minus half is also here. So what will happen is minus half and plus half will cancel. There is only minus. Okay, let's go to the next problem. Have we done it properly? So minus half is here. And when you take this whole square, it's minus half and yeah, this one you can write the answer. Let's go to the next problem. So this is the final answer. Dx over root of 7 minus 6x minus x square. See, these are all the problems where you need the knowledge of completing square. In fact, there was a chapter in 10th standard in quadratic equation, completing square method. Unfortunately, that was removed. See, whatever we require in college is what we have learned from 7th standard, 10th standard, maximum. Tomorrow, if you are taking any competitive examinations also, these basics are very important. And some of the students I have found, they find it completing square method difficult. Once you can bring it, completing square method, use it, then you can use the formula. So I'll be just, after working this problem, or before working this problem, I'll work 1 or 2 problems extra, only just to teach you how to complete the square. Let's go for one problem. 9x square plus 6x plus 5. So the method is, you have to complete the square and use the formula dx over a square plus x square, or things like any formula, suitable formula you can use it. So what is the method is, always look at the first 2 terms. I'm not working in the integration problem, I'm just teaching you, I'll come to this problem later. I'm just teaching you how to complete a square. Any problem given, first look at these 2. So you can write this as 3x, because plus sign is there, plus 1 or 2 you should decide. How? If I write 3x plus 1, I'll get 9x square plus 6x. Okay, 1 only. If I write 2, I'll get 4, or rather 12x, but you have got 6x, so 3x plus 1. 5 is there, that 5 you keep it as it is. Okay? Now you expand this. When you expand this, you get 3x square plus 6x plus 1. One extra you are getting. Subtract that 1. So what do you get here? 3x plus 1 whole square plus 2 square. Then you can work the problem. Supposing it is an integration problem, dx over 3x plus 1 whole square plus 2 square. What is the answer? 1 by 6. This 1 by 6 you should understand. 1 by a is because of 2, and that 3 you get because difference of 3x plus 1 is 3. 1 by 6 tan inverse 3x plus 1 by 2 plus. I have explained this in more detail when I discuss the question papers. Normally, what you have got to do is you have to take 3x plus 1 ST and work it out. I have just taught you there is no need of that. You can directly use the formula. Remember to differentiate this. Whatever expression is here, 3x is there. You get 3. So take 1 by 3 into 1 by 2, 1 by 6. I'll just teach you one more problem. How to complete a square. X square plus 2x plus 2. 2x plus 2. Now what you can do is look at the first two problems. It's very clear. You have to write this as x plus 1 whole square. You have written 1 extra because 1 subtract that 1. Then you write this 2. So what do you get? X plus 1 whole square. That's 1 square. Sometimes they give a problem. Normally, x square minus 6x plus 13. Normally in the CET, they won't give a number which is not a perfect square. 2x square they don't give. Supposing it is given also, I'll just tell you how to work it out. That takes more time. But the examiners are very cautious, see that you can't, contract is not possible to work. It takes more time. So here again, we can write this as x minus 3 whole square. We'll get x square minus 6. You subtract 9. 5. When you expand this, you get x square minus 6x plus 9. At 9 you subtract. Then you write this 13. So you get x minus 3 whole square plus 2 square. So just work one problem where it is a little difficult. I'll take a difficult problem only. 3x square plus 13x minus 10. There are two methods for this. First method is because this is not a perfect square. We want perfect, so we multiply by 3 and make it 9x square. Or we can divide by 3. Two possibilities are there. But when you divide by 3, you are getting 13 by 3 fraction. So let us avoid the fraction and multiply by 3. So what we do in the examination is, or when suppose the problem is given like this. So when you divide by 3, when you multiply by 3, you should multiply even and also by 3. So we write 3 dx over 9x square plus 39x minus 10 by 2. You can't avoid the fraction. Somewhere the fraction will definitely come. But let us look at this. You have got 9x square plus 39x minus 10 by 3 is there. Just you have to write 3x. There is no other way. Now I want 39. So if I write 13, what will happen? If I write whole square here, I'll get 9x square. And tell you this type of difficult problem will not be given in the CET. I am just working out in case if it is given. And given instruction, when you know your difficult problem, do it in the third round. Okay. Now, if I expand this, 2ab is 2 into 3 into 13. You will get 39 into 78. You will get. So we don't want that 2. Therefore, we divide this. Right? So that this 2 will cancel. So, what is that we have done now is 3x square plus 39x. The extra we have written is 13 square, that is 169 by 4 minus 10 by 3. Why minus 10 by 3? You simplify this. What's the LCM? Sorry, 169 by 2 is 169 by 2, not 2. 169 by 3. Because 2AB, 2 into AB into B. So, sorry, 2AB should get 39. So, you should take 39, 13 by 2. And you have got 10 by 3. You have got to simplify this. It takes a lot of time. But let us not waste our time here. Such problems will not be given. In case if it is given, the best thing is you can differentiate the answers and work. It will not take more time. Okay. Let's complete this problem. Here, you have to complete a square for 7 minus 6x minus x square. So first write this as x plus 3 whole square. Because when I expand this, I will get x square plus 6x plus 9. So when I multiply minus 1, I get minus x square minus x minus 9. Because minus 9 is there, I should write plus 9 here. So the 9 and 9 is cancelled. But 7 is already there. So this is 4 square minus x plus 3 whole square. So dx over square root of 4 square minus x plus 3 whole square. That is equal to, directly if you take the answer, x plus 3 by 2. So completing square method, normally they give very simple problem. Always look at the first two terms, write that, and whatever extra term is there, you subtract that. Then you can simplification, but it's very easy. Let's go further. Another interesting problem. Sin 2x into sin x dx. There are two ways of working this. Sin A, sin B. Sin A, sin B. What is sin A, sin B? Half of cos of A plus B minus, cos of A minus B minus cos of A plus B. So if you use that, you get cos A plus B is cos 3x and A minus B is cos x minus cos 3x dx. So the half of minus cos x is sin x minus sin 3x by 3 plus. Let's go to the next problem. Two minus x over 2 plus x dx. So what we should do is, denominator got x plus 2. Numerator also can get x plus 2. So if I want x plus 2, I can write as a minus of x plus 2. So that I can divide by x plus 2. So what should I write here? I should write 4. So this adjustment you have to learn. If I simplify this, 4 minus 2 is 2, 2 minus x. So I am separating this. So what will happen? This will cancel. So what is the answer? 4 log x plus 2 minus x plus 2. See, the problem is very simple. Only thing is you need to learn this method. This method, you have to learn. How to learn now? That's what I told you, work as many problems as possible. So this technique, adding something, subtracting something, and this is a very familiar formula. Dx over log of ax plus b is 1 by a log ax plus b. That formula I can use it. The next problem. Dx over. I appreciate the people who have considered this problem. The person, because while working, you must appreciate them and enjoy working such problems. Beautiful problem. So at the most, what you can do is you can write cos square x plus sin square x and 2 sin x 1 plus sin 2x. You can't proceed. The beauty of this problem is dx over, you take cos x common. What do you get? 1 plus tan x whole square. This is the beauty of the problem. That's what I told you. While working such problem, appreciate the person has considered the problem. It's very, very important. So enjoy working such problem. See what a beautiful problem. So what will happen to this cos x? We can shift it denominator. It becomes secant square x. What do you get? 1 plus tan x whole square. So simple. Put 1 plus tan x equals t. You get secant square x dx is dt. This is t to the power of minus 2 dt. That is minus 1 by t plus t. That is minus 1 over 1 plus tan x. The entire problem lies in knowing that you have to take cos x common. How do you know that? I am teaching you. How do I know? I learned from my teacher or from books. So these are all the problems where you should have worked earlier. Maybe a similar problem, then you can try by trial and error. Unless you are exposed to these as problems, it's very difficult. So exposing yourself to as many problems of different types. The next problem they have given is cosecant x by 2 into cot x by 2. Cosecant x by 2. You have got a similar problem already. So you can write this as cos x by 2 by sin square x by 2. The only thing is, earlier problem had a cos x by sin x, x by 2 is there. That is one extra thing you should know. So put sin x by 2 equals t. Cos x by 2 dx is minus 2 dt. No, minus half dt. Why minus half? Cos x by 2. Sorry, 2. So this is half you get here. This becomes 2. When you differentiate sin x by 2, you get cos x by 2. And difference of x by 2 is half. And like sin x by 2 is cos x, there is no minus, I'm sorry. There is no minus sign. So in integration, you get a minus sign. Sin x by difference of cos x by 2. Difference of x by 2 is half. But I have sent it here. So what is the problem now? This is 2 t to the power of minus 2 dt. That is 2 by t plus 1. That is minus 2 by what is t? Sin x by 2. That's 1. Or you can write as minus 2 cosecant x by 2. Plus. Let's go to the next problem. These are all problems where it is giving us some new methods, little more deeper into the concept. Sin x cos x over 4 plus cos square x. Yesterday I discussed if cos x is t, sin x minus sin x dx. If cos square x is t, it is minus sin 2x. If sin square x, or rather what I said yesterday was, should remember the derivative of cos square x is minus sin 2x and derivative of sin square x is plus sin 2x. So here we have got sin x cos x. Sin x cos x is half sin 2x. Therefore what you can do is, you take 4 plus cos square x itself plus t. This is minus 2 sin 2x dx is equal to dt. So this is sin x cos x is, we have got sin 2x. What is sin 2x? 2 sin x cos x. So this is sin x cos x is equal to minus half dt. Because sin 2x is 2 sin x cos x, shift it there. So this is going to be, this is what you should realize. See the beauty of the problem. Normally what we do is we take the cos x as t, and it's possible if they are given sin x there. Cos x is also there. Therefore, you take the entire thing as t, and you should remember that derivative of cos square x is minus sin 2x, derivative of sin square x is plus sin 2x. So what is the problem now? Minus half dt by t, that is minus half log t plus t, that is minus half log of 4 plus cos square x. Solve the problems which is giving us some more ideas, a little more deeper into the concept. Tan cube x into secant x dx. If you take tan x as t, you get secant square x. They are not given secant square x. Therefore, taking tan x as t will not work out. So what we can do is, you can write this as secant square x minus 1 into secant x tan x dx. So one tan x you leave it like that. The other what is left over is tan square x. No, it's very simple. Put secant square x equals t. I'm sorry. Put secant x equals t. What do you get? Secant x tan x is dx is dt. So this is going to be dt. So what do you get? You get t square minus 1 dt. That is t cube by 3 plus c. Sorry, t cube by 3 minus t plus c. But what is t? Secant cube x by 3 minus secant x. So simple, provided you had worked earlier. Let's go to the next problem. Integrate, very simple one. Still, I have taken this. Cos x minus sin x over cos x plus sin x. I have suggested earlier, let me remind you again. In a working problem of integration, if you have got quotient, normally we take denominator as t. So that after differentiation, you can't, the derivative will not come to denominator. But there is an exception for that. What is an exception? If it is an inverse function or logarithmic function, because if it is an inverse function, derivative comes to denominator, or logarithm also. Other than that, whenever you find quotient, you always take denominator as t. So what is given here? Put cos x plus sin x is equal to minus sin x plus cos x dx. So realize this is nothing but this. A very simple problem. dt by t, that is log of cos x plus sin x. There the confusion is, they have given cos x minus x, you are getting minus sin x plus cos x. Should realize they are one and the same. This is where in the examination the confusion happens, especially in CET, because you will be in a hurry to complete the problem first thing. You spend a lot of tension, and there might have been, you would have seen some difficult problems, which has definitely put your confidence down. So when in the first class when I discussed, I have given all these ideas. When you find a difficult problem, don't lose confidence, postpone that problem. The next problem is sin 2x cos 2x over 1 plus cos square 2x. See, cos square x is cos 2x. Sorry, derivative of cos square x is minus sin 2x. Here they have made cos square 2x. So you take 1 plus cos square 2x itself as t. So what is the difference of this? 2 cos square, 2 cos 2x, because chain rule, 2 cos 2x. Then if you differentiate cos 2x also, you get minus 2 sin 2x dx is equal to t. So cos 2x sin 2x dx is minus 1 by 4 dt. Very simple problem to realize. So this is minus 1 by 4 dt by t minus 1 by 4 log of 1 plus cos square 2x. So today I worked most general problems to give you a little more ideas about integration. Tomorrow I will be discussing about CET problems, KCET problems. Though I was, my intention was to discuss CET problems only, I thought by exposing you to these types of problems, you will get your confidence level will boost and you will get little more ideas. You get more ideas. In fact, the problem that we have worked today, I personally feel will certainly give you little more depth of concept. And this will certainly help you for tomorrow's class. Tomorrow I will be discussing the problems which have appeared in KCET. There may be some repetitions also. And there are some problems very simple. And there are some problems which require more steps. And there are some problems which I would rather say untouchable problems. Very difficult. Such problems you have got to skip. 5 problems I keep telling from the first class. 5 problems you can always skip. Or you can, at the end of the session, you can take any answer and then tomorrow. By chance, if it is correct, you will get marks. Otherwise, you don't lose any marks. So today we'll stop. Tomorrow we shall discuss KCET papers. Thank you and good night.